Lesson 7-3, Solving Multi-Step Inequalities. And in this lesson, you learn to solve linear inequalities involving more than one operation, and to find the solution set for a linear inequality when a replacement set values are given for the variables. Why is it important? Because you can use inequalities to solve problems involving engineering and real estate. Let's take a look at this example, real-world application in engineering. Rosa Whitehair is a partner in an engineering consulting firm. Her fee for consulting on large construction projects is $1,000 plus 10% of the design fee that the firm charges its clients. Ms. Whitehair is considering two construction projects, a 50-story building and the design of an airport terminal. She is interested in both projects but decides to choose the one for which her fee is higher. The company that is designing the office building has agreed to pay Miss Whitehair flat fee of $5,000. How much does the design fee need to be for her to choose the terminal? Okay, so to answer this, let us X represent the design fee for the airport terminal. Okay, so you have your flat fee for $1,000. Okay, plus the 10% of the design fee, and 10% is zero point 0.1 as a decimal, 0.1x, okay, is more than, obviously, the flat fee of the office building, which is $5,000. Okay, so we want to solve this inequality, and if you notice, this is not a one-step inequality anymore. So this inequality involves more than one operation. It can be solved by undoing the operations in reverse of the order of operations in the same way you would solve an equation with more than one operation. So you have 1,000 plus 0.1x greater than $5,000 or 5,000. You want to solve for x, so you subtract 1,000 to both sides of your inequality. So you end up with 0.1x greater than $4,000. Okay, and divide both sides by 0.1, and x would be greater than $40,000. So if the design fees are higher than $40,000 for the terminal, Ms. Whitehair will choose this project since her consulting fee would be higher for this project. Okay? Let's take a look at example number 1, see how to solve this problem. Determine the value of x so that angle A is acute. Okay, so we have this angle. Angle is 3x minus 15 degrees. Okay, assume that x is positive because there's no such thing as a negative number in an angle measurement. Okay, so for angle A to be acute, its measure must be less than 90 degrees. Remember the definition of an acute angle. It's a measure of an angle that's less than 90 degrees. Okay, thus 3x less than minus 15 is less than 90. So we need to solve for x, and 3x minus 15 is less than 90. Undo negative 15 first by adding 15 to each side. End up with 3x less than 105. And undo 3 by dividing both sides by 3. You end up with x is less than 35. So for angle A to be acute, x must be less than 35. Okay? Sometimes inequalities like equations involve variables on each side of the inequality, just like example 2. If you want to solve negative 4w plus 9 less than or equal to w minus 21, you notice there are variables on both sides of the inequality. So in this case, we want to undo one of the inequalities. In this case, we want to undo w. So first, we copy the inequality. and then we subtract w to both sides of the inequality. Subtracting w to both sides of the inequality will give us negative 5w plus 9 is less than or equal to 21. Then we undo positive 9 by subtracting 9 to both sides. End up with negative 5w less than or equal to negative 30. Divide both sides by negative 5. But since you're dividing by a negative number on both sides, the inequality reverses. So you have now w is greater than or equal to 6. Okay? So the solution set is w such that w is greater than or equal to 6. When we solve an inequality, the solution set usually includes all numbers for certain criteria, such as x such that x greater than 4. Sometimes a replacement set is given from which a solution set can be chosen. Let's see what this means. Determine the solution set for 3x plus 6 greater than 12 if the replacement set for x is negative 2, negative 1, 0, 1, 2, 3, 4, and 5. So these are the only numbers that you need to choose from to find out, to replace for x. So method 1, substitute values into the inequality to find the values that satisfy the inequality. Okay, so if you try negative 2, okay, copying the inequality, substituting negative 2 to x, you end up with 0 greater than 12, and that is a false statement. Okay, so from this trial we can estimate that the value of x must be greater than negative 2 to make the inequality true. So let's try 2. So again, using guess and check, we copy the inequality, substitute the value of 2, end up with 12 greater than 12, which is again false because 12 is not greater than 12. Again, from this, what can we gather? From this trial, we see that the value is greater than 2 must be in a solution. Now let's try 3. So if you have 3x plus 6 is greater than 12, trying 3, we find that this makes the the inequality true, the sentence true. So the solution set in this case would be 3, 4, and 5. So this method 1 is mostly, okay, trying it out, or better yet, make a table out of this. Okay. Method 2 would be a lot simpler, a lot shorter to do, because in method 2, solve the inequality for all values of x, then determine which values from the replacement set belong to the solution set. So all you need to do is solve for x. So you have 3x plus 6 greater than 12, subtract 6 to both sides, end up with 3x greater than 6, divide both sides by 3, okay? You end up with x is greater than 2, okay? So from there, the solution set is those numbers from the replacement set that are greater than 2. In this case, it's only 3, 4, and 5, which are greater than 2. So solution method 2 would be a lot faster to use, okay? Because after you find the solution, all you need to do is look at your replacement set and see what values apply to your solution. Okay, and let's take a look at the last example. When solving some inequalities that contain grouping symbols, remember to first use the distributive property to remove the grouping symbols. Example number 4, solve 5 times the quantity k plus 4 minus 2 times the quantity k plus 6 is greater than 5 times the quantity k plus 1 minus 1. Then we want to graph the solution. Again, these are there are expressions on both sides of the inequality, and as we learned in solving equations, we need to simplify both sides, okay, before solving for x. So that means you need to simplify both sides, both expressions before solving for x. In this case, before solving for k. So first things first, we use the distributive property. Using the distributive property for this one, we end up with 5k plus 20 minus 2k minus 12 greater than or equal to 5k plus 5 minus 1. Parentheses is gone. Remember when an expression is in simplest form is when there are no parentheses and there are no like terms. And that's what we want to do. We want to simplify by getting rid of parentheses and getting rid of like terms. So we still have like terms, so we simplify further. 5k plus minus 2k is 3k, 20 minus 12 is 8, and then 5 minus 1 is 4, so you have 3k plus 8 is greater than or equal to 5k plus 4. Okay, now both sides have been simplified. Now we need to decide which variable we want to undo. We want to undo one of the variables, so we want to undo 5k by subtracting 5k to both sides. In doing that, we end up with negative 2k plus 8 is greater than or equal to 4. Okay, we want to undo positive 8 by subtracting 8 to both sides. End up with negative 2k greater than or equal to 4. And then we want to get rid of negative 2. That means we need to divide both sides by negative 2. But once you divide both sides by a negative number, okay, in an inequality, the order reverses. Order of the inequality reverses. So you end up with k is less than or equal to 2. And then to be able to graph this inequality, since the solution set is k such that k is less than or equal to 2, okay, this is the graph. If the closed dot on 2, since 2 is included in the solution, and since it's pointing to the variable, okay, the arrow goes to the left. Okay, and the secret word for this particular lesson would be the word Dalmatian. The word Dalmatian is the secret word for this particular lesson. And that's our lesson. Thank you for watching.